Good morning, students. Today I am here with you a new topic, the eyeball. I am Dr. Ambali and we are dealing with the eyeball today. So, you have seen the bony orbit and many structures that moves the eyeball and supplies the eyeball. And you have studied about the optic nerve. Now, you are going to learn about the eyeball in detail. Where is it located? It is in the anterior one-third of the bony orbit. The rest is occupied posteriorly, it continues as the optic nerve. Then it is covered by it is covered by the optic fat. Okay, behind the optic, the movement is cushioned by the optic fat or the orbital fat. Okay, now all these are covered by a Tenon's fascia or the fascia bulbi. You can see the Tenon's fascia when the eyeball, orbit and all these structures has been removed. You can see it as a socket and it is clinically very important, like in implantation of an eyeball. If you have to remove this eyeball either in a tumor or trauma and you have to implant an artificial eye or something, this Tenon's fascia acts as a socket. Okay, so behind the eyeball it continues as the optic nerve. Now the structure of the eyeball. So it is mainly the general structure. The eyeball is divided into two compartments by the lens, the crystalline lens. Anterior to the crystalline lens, it is the anterior compartment, or it is called the anterior segment. Since it is filled with aqueous humor, it is also called aqueous compartment. Posterior to the lens, here it is seen as blue colored thing, the major part, it is filled with vitreous. So this is called the posterior segment or the posterior compartment, or also called the vitreous compartment. Now you see the anterior compartment. The anterior compartment is again divided into two by the diaphragm iris. Here, this red colored part between the iris and the cornea, it is the anterior chamber, and between the iris and the lens, green colored part is the posterior chamber. Okay, both the anterior chamber and the posterior chamber, it contains aqueous humor, so together it is known as aqueous compartment in front of lens. All these are covered by three layers or coats. This is the general structure or general arrangement. The anterior and posterior compartment separated by the separated by the lens, and the anterior and posterior chamber separated by the iris, and is continuous through the pupil. Now about the tunics or coats of eyeball. You can see the outer coat is fibrous, which is comprising of sclera and cornea. The sclera is opaque and cornea is transparent. Now inner to the sclera, there is a second layer or the middle coat. You can see here is red colored coat. It is vascular coat. So the middle or vascular coat, which comprises of choroid, ciliary body and iris. Then inner to it is the third coat or the neuronal layer or the nervous coat. It is composed of retina. So now you can compare these with your brain. The brain with its meninges or the coverings. Here the dura is replaced by the sclera. Then the brain, it is represented by your retina. So what comes between the brain and the dura? It is the pia arachnoid. Yes. So here the pia arachnoid is represented by the vascular pia. The pia arachnoid is represented by the choroid. Okay. I hope you know the eyeball is considered as a continuation of brain. So, and the optic nerve has the same coverings as that of brain. The optic nerve with dura mater, arachnoid and pia. Yes. So the eyeball is also can be considered as a continuation. So with that, we are coming to in detail about the outer or the fibrous coat, which comprises of sclera and cornea. So when you open your eyelids, you can see both the sclera and cornea, almost the entire cornea, circular, and on either side you can see the white of the eye. That is the sclera. So wherever you can see the sclera anteriorly, it is covered by conjunctiva. Okay, posteriorly, so when you remove the eyeball, it is a globular structure, and the rest of the sclera is covered by the connective tissue and the Tenon's capsule. So when you take a cross section, here again you can see these two, the sclera and cornea, are almost a segments of two circles. The sclera is that of a segment of a larger segment of a larger circle, and cornea is a smaller segment of a smaller circle with more curvature. Okay. Now, the mainly you can describe it as that though it is fibrous, both are fibrous. Whether it is the cornea or the sclera, it is fibrous. But the difference is one is transparent and the other is opaque. Okay. So the outer coat or the fibrous coat comprises of a transparent cornea and an opaque sclera. Okay. Then what makes it? Though so both are formed by the collagen fibers, but the transparency is due to the regularity of arrangement of the collagen fibers. Here, the collagen fibers are arranged in such a fashion that there's a regular arrangement, there's a peculiar arrangement in a regular manner that permits light or makes it transparent, whereas in sclera, it is haphazardly arranged and make it opaque. Okay, that is the main feature of the cornea. Now we can come to the sclera. What is the function of sclera? The sclera is the white of the eye. It forms, or it is considered the skeleton of the eye. It gives the strength and rigidity or the shape of the eyeball. Okay, then it also gives space or works as a medium for attachment of the extraocular muscles that has to move the eyeball. Okay, so this is the function. Then there are several structures that pierce the sclera to enter the interior. So you can see the posterior aspect of the sclera. Now you are seeing the posterior aspect of the eyeball, and in the center what you are seeing is the optic nerve. It is cut. The optic nerve is formed by several fibers from the retina and pierce the sclera to come out to form the optic nerve. So when there were several structures pierce a small area, it becomes sieve-like. Now you know how to name a sieve-like structure. It is cribriform. Okay, so this part of sclera is called the lamina cribrosa, and it is limited naturally by the attachment of the dura mater around the optic nerve. Okay, so the lamina cribrosa is pierced by the optic nerve fibers and the central retinal vessels. Now, in the picture you can see around the optic nerve there are several circles, smaller circles, which is red, blue and yellow. So these are the vessels and nerves that pierce the sclera from behind. So it is named posterior ciliary arteries or vessels. We can come to the vessels first. This is the posterior ciliary vessels, but some of these are short and ends by supplying the structures within the eyeball. Two of these are very long and it reaches up to anteriorly. Okay, so accordingly, these vessels are named short posterior ciliary vessels and long posterior ciliary vessels. Along with that, the nerves are short ciliary nerves. All these will be piercing the posterior aspect around the lamina cribrosa or the optic nerve. Then, in between the muscle attachment and this lamina cribrosa, you can see some veins, 4 or 5 veins. Here it is marked as VC. These veins come out piercing the sclera and around the equator. They are named as venae verticose. Okay, venae verticose, which will drain into the superior inferior ophthalmic veins, the veins of orbit. Okay, then next structure that pierces the sclera anteriorly, more anteriorly, along with the attachment of the muscle, it is the anterior ciliary vessels. So these are the 4 structures that pierce the sclera. Okay, the lamina cribrosa, the posterior ciliary vessels, short and long, and nerves, venae verticose, and anterior ciliary vessels. Okay, now come to the cornea. Again, you must remember there were 4 structures piercing sclera. Here also there are 4 features you should remember about cornea. 4 features. One is nothing but its transparency. Okay, now you know how it is made transparent. Other than this regularity of the arrangement of the collagen fibers, the type of collagen fibers, its hydration, and the chemical nature of the stroma, all these are important. Okay, though the main feature we will say it is the regular arrangement of the collagen fibers. But what is more important is its transparency. Adding to its transparent nature, it is an avascular structure. There is no blood vessels directly supplying the cornea. It is avascular. It is transparent and avascular. Okay. So this avascularity also contribute to the transparency of the cornea. I'm telling this because whenever the cornea is abnormally vascularized, it is called pterygium, a small part with a blood vessel, it encroaches the cornea. It is a disease and it has to be removed. The vision is affected and it will cause partial blindness. Okay, so avascularity even without the lymphatic vessels. Okay, and the more important is it makes the cornea more ready, more acceptable for the transplantation easily. Okay, so the third point regarding cornea is, now you know doesn't have an arterial supply. What about nerve supply? Try to touch your cornea. What happens? It automatically blinks. No. So it is because it is highly sensitive. Okay, highly sensitive. There is rich nerve supply, sensory supply. Which is the nerve that supplies the cornea? Whatever be the structure, if it is on the face, it should be supplied by a branch of trigeminal nerve. Which division of trigeminal nerve? It is the ophthalmic division. So you can say it is the nasociliary branch of the ophthalmic division that supplies. Whatever it be, even if you don't remember that, just remember it is highly sensitive. Okay. Then the fourth point is this cornea provides the maximum refractive index or refraction to the light that passes through. Okay. The light from the outer side to reach the retina, it has to pass through several refractive media: the cornea, the aqueous humor, the lens, the vitreous humor. Of these, the major part of this refraction is at the junction of air and the cornea. So these are the 4 structures you should remember about cornea. Its transparency, avascularity, sensitivity, and the refractive medium. Now, if it is avascular, no blood vessels to supply it, still it has to get its nutrition. So from where is the cornea nourished? So when there is absence of blood vessel, there will be more than one source to supply. Which? So at the periphery of the cornea, there are the conjunctiva and there are some episcleral vessels, conjunctival vessels, etc. that loops back, and it gets nutrition from the diffusion from the peripheral vessels, from the periphery of the cornea. Second, what lies behind the cornea in the anterior chamber? It is the aqueous humor. So the aqueous humor supplies it from behind, and what lies anterior? Your cornea is always kept moist by a thin film, a tear film, or it is also called the lacrimatory fluid that supplies from the anterior aspect of the cornea. Okay, along with the atmospheric oxygen. Atmospheric oxygen directly supplies through the lacrimal fluid. So these are the four source, again four structures piercing sclera, four features of cornea, and four sources of nutrition to the cornea. Now about the corneal reflex. You can see when the cornea is attempted to touch with a cotton, what happens? Immediately blinks. So the afferent limb of this reflex is taken by the sensation, that is the ophthalmic division of trigeminal nerve, and the efferent limb is the blinking. So any movement of on the face, it is the facial nerve. That is the corneal reflex, and it is because the cornea is highly sensitive. Now next thing about the cornea is its corneal ulceration and opacity. Told you it is transparent, and when any ulcer, sometimes when you can't close your eyes, as in Bell's palsy and all, it is always kept open and the cornea will dried up. Sometimes your tear film, it doesn't have a quality, so that also leads to the corneal dryness. And whenever this is dry, or when there is some trauma occurs to the cornea, there will be some corneal ulceration and leads to opacity of the cornea. So when the cornea is opaque, again you are not able to see, it also is called blindness. But these are all reversible causes of blindness. Now what will you do? You will remove a part of that cornea, and the cornea will be transplanted from a healthy donor. Okay, so this is called the corneal transplantation. And can you see here the cornea is sutured back? Can you see the sutures on the periphery of the cornea? Yes, this is called corneal transplantation or keratoplasty. And you remember, wherever you hear kerato, it is related with the cornea. When there is a coning of the cornea, it is called keratoconus. Okay, in transplantation of cornea, it is called keratoplasty. Then cells of the cornea, it is called keratocyte. Don't confuse it with keratinocyte. Okay, so now about the sclerocorneal junction. The sclerocorneal junction, you can see when you look from anterior, it is a circle at the junction of sclera and cornea, and it is called the limbus. Okay, and when you take, this is the limbus at this junction of sclera and cornea, there's a slight depression. And when you see this cross section, you can see at the junction of the sclera and cornea, there is a venous sinus, a small cavity lined by endothelium. It is called, this venous sinus is seen inside the sclera, so it is called venous sinuses sclerae, and it is named after an anatomist. It is also called the canal of Schlemm. Okay, just remember the spelling, it is double M. Okay, it is the canal of Schlemm. It is clinically very important. I will come to it later.
Today I am going to demonstrate the specimen of eyeball. So I have taken the bull's eyeball to demonstrate. Eyeball occupies the anterior 1/3 of the orbital cavity, and it is embedded in fat. And it consists of segments of two spheres. An anterior 1/6 represents the small sphere which forms the cornea, whereas the posterior 5/6 belongs to the larger sphere which forms the sclera. Coming to the poles of the eyeball has got an anterior pole and a posterior pole. Anterior pole is at the center of curvature of cornea, whereas the posterior pole is situated at the center of the posterior curvature of the eyeball, and it is slightly lateral to the optic nerve. This is the optic nerve. So the optic axis or the geometric axis is the line joining the anterior pole and the posterior pole. So in order to view the codes or the tunics of the eyeball, you have to cut open. So before that you can see the outer fibrous coat of the eyeball. The outer fibrous coat of the eyeball consists of cornea anteriorly and the opaque sclera posteriorly. Sclera forms the posterior 5/6 of the fibrous coat. It is white and opaque, and on the inside it is brown, which we will see later. Sclera is continuous with the cornea at the sclerocorneal junction. And this is the cornea, which is transparent and the avascular part of the fibrous coat. So this is the optic nerve seen on the posterior aspect. The sclera has got the weakest part of the sclera is called the lamina cribrosa, where the axons of optic nerve pierce the sclera to lead the eyeball. So this is the optic nerve, and which pierces the lamina cribrosa. And you can also see the extraocular muscles which get attached to the sclera. Sclera is also pierced by the posterior ciliary vessels, which is seen around the optic nerve, and the anterior ciliary arteries perforate the sclera close to the sclerocorneal junction. And there are also 4 to 5 venae verticosæ that will pierce the sclera midway between the optic nerve and the sclerocorneal junction. So these are some of the structures that pierce the sclera.
So thank you, Nida, for the demonstration of the outer coat of the eyeball. Now we will come to the vascular coat in the next part. Thank you.